Question 4c. In the diagram, the shaded region is bounded by the curve y equals 2 times sec x, the coordinate axes, and the line x equals pi over 3. The shaded region is rotated about the x-axis. Calculate the exact volume of the solid of revolution formed. The solid of revolution is formed by rotating the curve about the x-axis. Hence, the volume V of the solid formed is given by V equals pi times the integral from x equals x1 to x equals x2 of y squared dx. Now, y is equal to 2 times sec x, but we need y squared to be the subject. So squaring both sides of this equation, we get y squared is equal to 4 times sec squared x. And the limits of integration are x1 equals 0 and x2 equals pi over 3. So substituting 4 sec squared x for y squared here, and 0 for x1 here, and pi over 3 for x2 here, the volume of the solid formed is equal to pi times the integral from x equals 0 to x equals pi over 3 of 4 times sec squared x dx. Now the 4 can be taken outside of the integral, which simplifies the integration. So the volume is equal to 4 pi times the integral from x equals 0 to x equals pi over 3 of sec squared x dx. Now the integral of sec squared x dx is tan x, so the volume is equal to 4 pi times tan x from x equals 0 to x equals pi over 3. Applying the limits of integration, the volume equals 4 pi times tan pi over 3 minus tan 0. And recall that tan pi over 3 is an exact ratio, and that equals the square root of 3. Therefore, the volume is equal to 4 pi times the square root of 3 cubic units.